All right, so practice 12, question number 12 says, suppose f of x is a differentiable everywhere. Okay, so what this differentiable everywhere means is that f is continuous everywhere. So from negative infinity to infinity, this function is continuous. Now, if this was free response, you would have to write that or you lose points. So when you see differentiable, you need to tell me that means continuous. Okay, and then it says this point is on the graph. So there's a point on the graph. It says f prime, the derivative, is less than or equal to 5 for all values in x. Okay, so let's see. We got -2, -5 is on the graph. We know that f prime of x is less than or equal to 5. And using the mean value theorem, okay, so we're going to use mean value theorem. What is the largest possible value of f of 8? So we want to know f of 8 equals what? Well, mean value theorem says that f prime of c is going to equal f of b minus f of a all over b minus a. So in other words, this right here is a point. This -2, -5, this is a point. So I'm going to let this be a. So this is f of a. And then over here, this 8, that's an x value. That's going to be b. So this whole thing is f of b. And then f prime, which is f prime of c, has to be less than or equal to 5. So what that means is 5 has to be less than or equal to this function. So f of b, I said I'm going to let b be 8. So f of b is f of 8. So I'm going to put f of 8 here. Oh, wait a minute. This should be the other way around. 5 is greater than or equal to these because this can be less than that. So this number's got to be the biggest. So let's see. F of 8 minus f of a, which is minus -5, is going to be 8 minus -2. So all I've done is plug these things in where they go into the formula. And now I got to solve this thing right here. If I solve that for this f of 8, that's going to be my value of f of 8. So let's do it. So I hope we all know that I can take minus a negative becomes plus a positive, and this minus a negative becomes plus a positive. So this means I've got this right here would be 10 in the denominator. So I'm going to take that 10 and multiply it over the other side and get 50. It's going to be f of 8 plus 5, and then I got to subtract 5 from both sides. So I get 45 has to be is greater than or equal to f of 8. So the greatest possible value for f of 8, since it's less than or equal to 45, is 45. So that's the biggest possible value for f of 8. So kind of a hard problem. We're going to go on to number 5 now. Number 5 says, here's the graph of h of x. So this graph up here is h of x, what it tells me right there. Which of the following is the derivative of h? Okay, well, we got to think about some things that we know about derivatives. So first of all, if h prime of x is greater than 0, that means h is doing what? Anybody tell me out there in the world? If the derivative is greater than 0, what's h doing?
Increasing.
Increasing. Okay? And if h prime of x is less than 0, that tells me h is decreasing. And if h prime changes sign from, I'm going to do from positive to negative, I have a max, because a positive, an increase to a decrease makes a max. And if h prime changes from negative to positive, I have a min. And if h prime equals 0, those are critical numbers, which means I could have a max or a min at those numbers. So let's use this information and see if we can figure out which one of these has to be H. So what is this H doing from here to there and from here to there? What's H doing in that yellow highlighted part? Can anybody tell me? What's H doing out of these things over here?
Increasing.
Increasing. So that means I have to have a graph. My H prime has to be above X over here on this side of this maximum point. I tried to draw this down here below it. Over here, it's got to be above, and on that side, it's got to be above. And in here, in that little part right there, it is not increasing, but it is decreasing. So it's got to go below in this little section here. So I got above, and in this little section below. So if you look, this does not go back above, right? So it can't be this one. This one is not above on the left and right. Can't be that one. Now this one is above and goes below and comes back up. That could be it, but we got a little problem here. What's it saying is happening right here and right here? Looks like it's going back towards well, anyway, let's just look at this real quick. What do I have right here? This would be a relative what? What would this be right here? Relative what?
Max.
Max. This is a relative max. So that means the graph should have been a positive to a negative at this place. So if I look, looks like to me right in here somewhere is about where that is on this. Does that give me a 0 at that place? Well, let's even say it is this place. There's a 0 right there. It looks like I got a 0 right here, don't I? I got 2 zeros there and there. So that'd be a max, and this would be a min right here. So it looks like that this and this could be mins because we're going, the derivative should go from decreasing to increasing there. Do you see this? Okay, so this goes from positive to negative, positive, negative, negative, positive. So these two things can both be where this is increasing and decreasing. Now there's one little thing here. Do you see how this thing continues to go down? Doesn't this mean that the decreasing, the slope is getting bigger and bigger and bigger because it's going straighter down, and this one's going straighter up as you go? See this little thing right here? There should be this has a 0 slope there, which means we should have a concavity change in our graph, in the original graph, because H prime is increasing to decreasing, so there should be a concavity change out here, and there should be one here, and there's no concavity changes because H prime again is changing from increasing to decreasing, and there's not any second concavity. The only concavity we have is right in here is a point of a poi, because this is concave down and concave up. So concave down to concave up means we'll only have one poi here. So let's see here. So it looks like to me, we're going to go with D, I believe. And it's mainly because this increase, or that decreasing and that increasing gets greater and greater, and this will be getting those greater and greater by still going up. Okay, I'm also going to give you another hint that we're going to talk about later to tell you why it's this one. This is a similar cubic graph right here, right? A cubic graph looks something like that. Y'all remember cubics? Disco left, disco right. And if we do a derivative of this, wouldn't this be an x squared? If f is an x cubed, then the derivative is an x squared, which is a parabola. So this cubic would go to a parabola, not to a function like this. This function right here would be a cosine sine curve because it looks like it's going to keep going up and down forever. Okay? So this should be D. Does anybody else? I'm going to pause this video. Okay, so 14 says on a closed interval, big deal that this says closed interval and absolute min. That tells me that we have a EBT if this graph is continuous, which it is a continuous graph. There's nowhere that you can plug any x in here you want, and sine is continuous values, and so e to a power is going to be a continuous graph. Now, if this was open, you would have to say f is continuous, and you would say on the interval they gave me. And since it does give you a closed interval, if f is continuous on a closed interval, that means EBT is applicable. In other words, there's a guaranteed max and a guaranteed min on this graph. So what we need to do to get EBT is we need to find the critical numbers. And to find critical numbers, you must do a derivative. So when you do a derivative of e, it's e to the same power and then times the derivative of that power. And the derivative of sine is cosine x. So this is going to be cosine x e to the sine x is what that's going to be. So we need to, now we need to find our critical numbers, which when we do that, that is going to be just a second here. Okay, so the critical numbers occur where f prime equals 0 or where f prime is undefined. Well, it doesn't matter what you put in here for x or what you put in there for x. There is no place this thing is undefined, so this is none. And then for this being equal to 0, you want to set one factor equal to 0, and you want to set the other factor equal to 0, and you want to find out when these are 0. Well, e to the sine x, now this is going to be a little different than what we're normally used to. This graph, e to the power normally goes straight up, but since sine goes from +1 to -1, +1 to -1, this graph is kind of going to go like this forever. But it never is going to be a 0. So I get no answers from this one. I get none from that because e to a power is never going to hit the x-axis. This one is, on the other hand. If you remember graphing cosine, we start at -1. I'm just going to give you a little review of pre-cal. So we start at -1 is a minimum, goes to a 0, goes to +1, goes to a 0, goes to -1, -1, and goes like this graph forever. It's a continuous cyclical function. It goes up and down forever. Or if you think about the unit circle, cosine is the x value, and x is 0 here and 0 down here going around the unit circle. So either way you do it, from the graph here or from this graph here, there are two critical numbers. There's pi over 2 and 3 pi over 2. And remember, in this class, you must use radians. So then on an EBT problem, you're going to make a t-chart every time. And then you are going to plug in the endpoints, which is the 0 from up here. And then I'm going to go in the order of my critical numbers going around the circle. And then I've got my other endpoint, 2 pi. So what I'm looking for here, I'm going to go back up and make sure I'm doing this right. I'm looking for I'm looking for the absolute min. I want the minimum. So I want the smallest number out of these right here. So I'm going to plug those into my original function. So this is e to the sine of 0. Well, 0 is right here, and the sine is the y value, which is 0. So e to the 0 is 1. Then pi over 2 is up here. So e to the sine of pi over 2 is e to the first. You need to know that this is approximately 2.718. You should get that memorized, e. Then I do 3 pi over 2 is this point down here, and the sine's this y value 1. So this is e to the 1, which is also 2.718. And then I got to do 2 pi, which is back here at this one, which is 0. So we're going to get e to the sine of 0, which is also 1. So it looks like to me, this is a weirdo. Did I miss one? Read this again. I'll make sure I didn't make a mistake here because this gives me 2. We want the absolute min of e to the sine of x. Pi over 2 cosine 0 e to the sine Make sure I didn't make a mistake on my derivative. E to the sine x cosine x, that's right.
Pretty sure 3 pi over 2 is e to the negative 1, so it'd be 1 over e.
Oh, this is negative 1. My bad. Yeah, I put 1 down here, and at the bottom it's a negative 1. So this would be negative 1. So what that means is there's our problem. I didn't put the right number on my circle. So this is 1 over e to the first, which is 1 over 2.718. 1 over 2 would be, that's almost a third, right? So this would be the smallest value. This is the minimum. Thank you for straightening me out. I didn't put a negative 1 at the bottom of my circle. All right. So it should be C. Thank you. I should have had that. So because I didn't draw my circle right, I put the wrong number in there for 3 pi over 2. I didn't put the ordered pair in right. All right, so we got that. Phew! Anybody else got one? All right. Well, I hope you guys have a great day, and good luck on the test tomorrow. And again, if you want to Zoom tomorrow, I'll be here. If you don't want to Zoom, that's fine. Don't forget you're taking the test tomorrow on AP Classroom. And then on Monday, the derivative test is on Canvas. So have a good day, and I will talk to you all tomorrow if you show up. If you don't show up, that's fine. Hey, don't forget, all the way through Tuesday, you still have to check into attendance. Okay? So you guys have a good one, and I will talk to you later. If you have any questions, email me. Bye.